We've left routing protocols and now are moving directly into access lists. The rules of the ACL, or the access control list. Access lists are one of the core pieces of Cisco routers, meaning you're going to be using them for all sorts of things. And that's going to be the first topic that we talk about as we get into access lists. They're not just for access. Even though that's what they're named, you'll use them for all kinds of stuff. And that's the first thing we'll talk about. Then we'll turn our attention to the security aspects of access lists in the sense that your Cisco router has the ability to be a pretty sophisticated firewall, allowing specific traffic in and out of the network. That's using ACLs for security. So we'll talk about ways to do that, and the final topic will be the types of ACLs that's able to do that. When you say access control list, that is more of an umbrella of many different categories of topics, two of which are the most important: standard and extended access control lists. We'll look at what those are and what the differences are. Access lists are everywhere in the Cisco world. It's one of those concepts that you'll hear repeated again and again and again. And it's almost unfortunate that Cisco named them access lists. I think they should have named them identifier lists. Because every time somebody thinks of an access list, they think of access. And they think, oh, this is like a firewall kind of thing to control access. Now, that's one of the things that they can be used for, but there are many more things that they can be applied to and used for that access would be somewhat confusing. So there's my proposal. We'll go ahead and change the name to identifier lists because that's exactly what they do. Identify traffic to be allowed or permitted or denied. Now, I know, even using that terminology, you're thinking, okay, permitted or denied to get out of the network or come into the network. You're thinking firewall. That's what I think when I think of it. And you can see right here what they are: a list of permit or deny statements. Permit 192.168.2.50, that host. Deny 192.168.1.0/24, that whole subnet. Permit just port 80 for 200.1.1.1. Now, this list of permit or denies really is almost better translated. See, look at this. I'm changing all the words. Allow or stop. Okay, I'm just making this up as I go, right? Let me talk about how they can be used, and I think that will shed a lot more light on what I mean. The number one way that people think about access lists being used is for access control, where in the truest sense of the word, they are permitting and denying traffic. So for example, I might have a router right here connected off to the internet, and as traffic comes in or leaves that router, I can say, well, who are you? Because if you're not invited here, you are denied. You cannot get in from the internet into my network. Or as they're going out, it'll say, who are you? Are you allowed to access the internet? Or are you allowed to access that website on the internet? That's access control. And that's where permit and deny really makes sense in our heads. But access lists can also be used for NAT. So for example, let's say this is our access list up here, this list of statements right here. We might apply it in such a way that says, this IP address is permitted to be translated using NAT off to the internet. As a matter of fact, if you look at this series, the next topic we're going to be talking about is configuring NAT from the command line. We'll go through some of the concepts and configurations, and we'll see how this is applied. But that's one of the things we'll do is we'll say we're going to create an access list and say that these hosts are permitted to be translated or denied from being translated. That doesn't mean they're being denied from accessing the internet as a whole. They're just being denied from the NAT process. They're not going to be translated to a public IP address when they go out. You could use it for quality of service. Tweak this example a little more and have this same list. I could say this host is permitted to receive priority on the network. That's what quality of service is all about, is prioritizing some traffic and deprioritizing others. So I can say that this host gets priority. So if there's congestion and things are being dropped, you know, the network's kind of overwhelmed, well that host is going to move to the front because they're permitted to receive priority. They're allowed to move to the front. The one below says deny 192.168.1.0 right here. If we apply it to quality of service, they are not denied from getting out or denied from accessing the internet like access control. They're denied from perhaps receiving priority. So you see, I could keep going down this list, demand dial routing, policy routing, route filtering, making French toast. Okay, access list, don't make French toast. But the point is that this is a partial list. This is one of those concepts you'll see repeating itself again and again and again in a Cisco world because there are many times, just think, any time that you're on a Cisco router, and you need to say these are going to be allowed or these are going to be denied to any process. And you just need to identify a group of IP addresses. That is where an access list comes in. When we talk about access lists initially, we'll talk about using them for security. And as we move into some of the other topics like NAT, that's where we'll expand some of those other uses. I just wanted to initially make sure you know these, even though they're called access lists, access is just one of the ways that you can use them. So if you are using an access list for security, it's like hiring a guard for your router to stand on an interface. Here's the idea. We've got this guard right here that we've assigned to stand on the fast Ethernet 0/0 interface. Now, as soon as we give that guard a list, he is going to screen all of the traffic either coming in or going out of that interface, depending on how we apply this access list, and say whether it's allowed or denied. So before we talk about the guard's processing, let's first talk about the rules of the access list. When you create an access list, it is literally just a list of statements like you see right here. It is read from top to bottom, and it will stop at the first match. So for example, we have this guard who has a list, and the first statement in that list, number 1 right here, says deny 10.1.5.1. So let's say he's filtering traffic coming this direction. He's going to ask that packet. Let's say that this is 10.1.5.10. The guard will ask and say, "Are you 10.1.5.1?" The packet says, "No, sir." And he says, "Okay." "Are you 5.3.1.2?" You can see statement number 2 in the list. Packet says, "No, sir." And then we come down here, you can see my little permits or whatever. This list can go on and on. We might say something like permit 10.0.0.0/8. Wow, that's big because that says permit everything starting with 10. You see the subnet mask right there. It's a class A subnet mask. So everything permitted with 10 is allowed. So he gets to that third statement and says, "Are you 10 dot anything?" And the packet says, "Yes, sir, I am." And he says, "Well, in that case, then you are permitted. You may proceed through into the router and access whatever resources that you have." So the list is read from top to bottom and it stops at the first match. What if this packet were 10.1.5.1 coming in? Well, the guard would say, "Are you 10.1.5.1?" is his first question. And when the packet says yes, it says smash. And the guard hits it with its gun right there, and the packet is destroyed and dropped. Now, even though the third statement in this list says permit everything starting with 10, since the list is read in order, it never gets that far. So you can see that the order is very important when you create an access list. Now, let's say we did something like this. Let's say we gave the guard a list that the very first statement, I kind of reorder it right here, is permit 10.0.0.0/8, the same statement we put down there. Well, if that's the case, then this packet 10.1.5.1 comes in, and the guard's first question is, "Are you 10.0.0.0/8?" And the packet says, "Well, yes, I am." Even though statement number 2 denies that packet, the guard never gets that far. Because it says, well, if you match that first statement, then you are allowed to go. You may proceed through. It never hits statement number 2. That's why the order is very important. Now, the second rule is equally important. The invisible implicit deny at the bottom of an access list. You can see that this list says deny all. But when you're configuring this list on a router, you don't see that there. Meaning you just start adding statements to your list. You say, okay, statement 1 is this, statement 2 is that, statement 3 is this. But all along, there's this invisible deny all at the very bottom of that list that just keeps getting pushed further and further down the more statements that you add to this list. So I guess you could state it in a way that says, if you are not explicitly permitted in that access list and you reach the bottom, you will be denied. There's no question about it. If you make your way all the way down through that list, you're going to hit the invisible deny at the bottom of the list. Now, You, as an administrator, can change that whole logic. You could actually, if you wanted to, as you're typing your list, you could say deny this, deny that, deny this, deny that, and then add a statement that says permit anyone. So you could put a permit. I'll just put per all, permit all before it gets to this invisible deny. So the guard will be going through his list and say, are you this, are you this, no, this, and, keep going, and then say, oh, well, then I guess you're permitted. So it never actually reaches the deny all, but do know that the deny all is still there. You're just not making it down to the bottom. It is an invisible implicit deny. Now, lastly, and this is one of the most difficult things when you're first getting into access lists, is the application. Access lists are applied to an interface inbound or outbound. Meaning you're going to create this list, and we'll say this is list number 5. The access lists are actually numbered, and we'll get deeper into this as we look at the config. So this is list number 5 with all these statements, and you're going to say I am going to assign list number 5 inbound on fast Ethernet 0/0. That application affects everything in the access list. When you say inbound, think about things coming in to that interface. So that would be, let's say, if there's a switch over here connected to a rest of a network, or maybe this interface is a DSL connection to the internet, or it could be connected to anything. As things come in to that router, that's where the access list will be applied. The best way I can describe to think about access lists and their applications is for you to become a router. Literally. Right now, this is video. You're in the privacy of your own home, or in a cubicle, just relaxing. Hold out your arms by your side. Come on, arms out. Hold them out. You can just put your fingers out if you're ashamed. You hold out your arms and you say, okay, my right arm, as I'm looking out at my right arm, which is pointing to the wall where I'm standing right now, my right arm is my fast Ethernet 0/0. My left arm, that's a serial port. Let me put my arm down for a moment. That's serial 0/0 over here on the router. My torso, me, am in the middle, and I am the router itself. So when I think about access lists being applied, if I think of them being applied outbound, serial 0, if I were to put out right here, look out your arm. That's your left arm that's pointing to wherever it is. If I apply an access list outbound, serial 0/0, that's going to catch traffic coming from me, the router, leaving that serial 0/0 to go to whatever this connects to over here. Could be the internet, could be whatever. So as traffic's going that way. So if somebody accesses me from the internet, the outbound access list does not apply. I mean, again, hold out your arm. Your arm is your left arm, serial 0/0. If you think about packets coming in your arm from your fingertips, traveling up your wrist, all the way through to your shoulder blade and into you, that came inbound, serial 0, coming in. Now, we could apply an access list outbound on fast Ethernet 0/0. That's your right arm. Again, hold out your right arm. Imagine, okay, both arms. Both arms are out right now, right? Imagine your left arm, serial 0/0, is connected to the internet. A packet just came from the internet. It's from a website. It's coming in your left arm, coming into your torso. You are the router. You're looking at the packet, and you go, oh, well, I'm looking at the destination IP address. I see that needs to go out my right arm, my fast Ethernet 0/0. So you send it out, and all of a sudden you notice, oh, wait a sec. There's an access list applied outbound on fast Ethernet 0/0. That's where this guard walks into the wire and now looks at that packet you're trying to send out your right arm and says, are you allowed? Let me look at this list. So when you're thinking about applying access lists, become a router. You are the router. Your appendages are the different interfaces of the router. I still, to this day, even after working with Cisco, I don't hold out my whole arm. I hold out fingers because people look at me with less. I just hold out a finger on each side. And I think, okay, this is the interface. This is the other interface. If you apply the access list wrong, if, for instance, you meant to apply it inbound, but you accidentally applied it outbound, it can destroy your whole company. And I say that is because, I mean, okay, I'm not going to even get into that. But it can have some very serious ramifications. We'll talk about that as we get deeper into it. Before we go any deeper, let's talk about the types of access lists that are out there. I always think access lists are like a category. They're like Skittles. There's many different kinds of them. You see right here that we have standard and extended access lists, and that's going to be where we're spending most of our time in this series. These are the main ones that we're going to be using in this series and in the real world to permit or deny different traffic types from being processed. Now, I'm going to spend plenty of time on those on the next slide. So let's just jump down to what we're not going to talk about. There are plenty of different types of access lists. I just want to give you an overview. Dynamic access lists are access lists that expand and shrink depending on who's going through at the time. Let me give you an example of dynamic access list use. You could have somebody that maybe has a username and password that they use to access the internet because not everybody at your company is allowed internet access. What you could do is you could set up a dynamic access list that says if this username and password comes in, meaning is typed in either via telnet or it could be typed in through a web page. There's different ways to set up dynamic access lists. If this username and password is typed in, allow that PC access for a certain amount of time. So for example, somebody could be sitting at a PC and they're like, oh, I need to access the internet. So they open a web page and it says, oh, what's your username and password? And they type that username and password in and it creates an access list. It gives that guard that's standing at the router a new access list that says this PC or this IP address is now allowed for this certain amount of time or until they close the web browser. You can set it up many different ways. Actually, I take it back. We are going to be talking about established access lists. So or they're also known as reflexive, which are, I'll talk about that later. We're going to talk about all of that on the next slide. Time-based access lists, we're not going to talk about in here. That's part of the CCNP track. Time-based is where the access list is active for a specific amount of time or time range. So with that, you could say, for example, internet access is allowed in my company after hours. Meaning during the hours of 8 a.m. to 5 p.m., if that's your business hours, internet access will be blocked. But as soon as you pass 5 p.m., that access list is removed or revoked, if you will, and allowed all night long until the morning comes around. And as soon as 8 a.m. comes back again, it blocks. Context-based access control, also known as CBAC, and that has now been renamed to the iOS firewall, is part of the CCSP, the Security Professional track. And that is where you truly turn on firewall features on your router, which enhances the capabilities of, well, I guess you could say every access list in the sense that it begins inspecting all the traffic that's going through. Not getting too deep into that because that is a whole feature set that's discussed in the CCSP. But you can think of that as a way to turn your router, your Cisco iOS router, into capabilities similar to the Cisco firewall line. Most of you may have heard of a Cisco PIX firewall or a Cisco ASA firewall. That's the firewall products they sell. That feature is what allows your router to do most of what the PIX firewall and ASA firewall do. Now let's turn our focus to the three specific access list types we'll be discussing in the CCNA series: standard, extended, and reflexive. Standard access lists match only based on source address. And I guess I could be more specific with that. Source IP address. So I can say that you are permitted or denied based on who you are, but not really what you're accessing or how you're accessing that device. So for example, if I have the internet right here, and this host will say 192.168.1.100 is not allowed to access the internet, I could just create a standard access list that says deny 192.168.1.100, and that does it. That's all you type in there. It says deny, and I could apply that maybe outbound on the internet connection. Remember, hold out your arms there. And that would deny that host from getting out onto the internet. Only based on source. I can't really say they can't access these sites on the internet, be selective with what sites, nor can I say they can't access the internet using TCP port 80, which is the web surfing protocol, but maybe use other protocols to access the internet. It's just based on source. So this has the lowest processor utilization of any access list because whenever you apply an access list to your router, the processor gets pumped up a little bit because it has to check every single packet going through against the access list. But if you use a standard access list, it only has to check the source IP address. It doesn't have to look at anything else. So it doesn't really slow the router down too much. The effect of this access list depends on the application. Meaning when I say deny 192.168.1.100. If I came up to you and you were a network manager in a company and I said, I have created an access list that denies 192.168.1.100. Your next question would be, denies them from what? What do you mean? What are you denying them from? Well, with the standard access list, that's all you can say is they are denied. Where I apply, that's what I mean in that third mark there, where I apply this access list is what determines the effect that it has. If I apply it outbound on serial 0, if that's what's connected to the internet, then they are denied from going out that interface and getting internet access. If I deny them out fast Ethernet 0/1, that might deny them from accessing an accounting server or that subnet that the fast Ethernet 01's attached to. Now here's a question. If I create this access list and apply it inbound on this interface in this little diagram I drew, maybe that's fast Ethernet 0/0, they're denied from everything. Meaning I might as well unplug that cable for that host anyway, assuming there's no other hosts on this network, because as soon as they try to come in the router, as soon as they try to get out their default gateway, come in that interface, the router's going to say, oh, I'm sorry, you can't come in here. Goodbye. Hang up, play that America Online sound. Goodbye. And they are disconnected from the whole network. That's why where you apply these things can have some severe effects. Now down here, extended access lists match based on source and destination address, along with protocol, along with source and destination port number. Now, I want to hit that little third mark I put under the extended access list. These do take some time to learn. I've had many people that I've talked to that just, extended access list. It's scary. It's because the syntax can be so long. I can essentially say with an extended access list, you are denied from accessing this host using TCP port 80 during these times of day, during, I don't want to get into all the access lists we're not talking about, but there's so much you can put in here. You can be very granular. So let's draw up our little host again. We've got that 192.168.1.100 connected to the internet. If I was or the heart. If I was using an extended access list, I could say 1.100 is denied from accessing, we'll say, google.com, the google.com's IP address, using TCP. That's the protocol that I'm talking about. I'm not talking about protocol as in TCP IP. I'm talking about protocols like TCP and UDP and so on. TCP destination port 80, which is web surfing. So at that point, when they go out, the access list says, are you going to Google? Because if so, let me check if you're using TCP. Oh, you are. And you're using destination port 80, then you're denied. But I could then say, but you're allowed to use anything else. So we're biased against Google or something and want to use Yahoo's search engine. So we could be very specific with that. It does have higher processor utilization, and the syntax is pretty complex. We'll see that in a moment. Reflexive access lists allow traffic, return traffic, for requests that originated from the inside of your network. Let me explain that in English. We've got an internet connection here, right? The internet is a scary place. We don't want, uninvited traffic to just be able to come in from the internet. So initially your thought might be, well, I don't know, I want to deny everything, deny all from the internet. And it sounds like a good idea. Any traffic that originates from the internet will be denied from getting into my router. But if you put a deny all on your internet connection, well, you just killed it. The internet connection will no longer operate. If somebody surfs the web, they will go out this direction. We'll say out serial 0/0 and access the internet, and that'll work just fine. But the problem is when the internet or whatever website they access, we'll say google.com, tries to return traffic to them. I mean, it's strange to think about it that way, but when you access the internet, sure, you're going out, but the majority of the stuff is returned to you. I go to google.com to request a web page, and Google sends it back to me. If I apply a deny all access list, the request will get there just fine. It's the response that will be blocked. So that's why we need these reflexive access lists. A lot of people call them officially TCP established access lists. What it will do is when my host goes out, the router puts on a little pair of glasses and says, aha, I just saw that host leave. So the source address left to go access google.com or whatever google.com's IP address is. So I will create a reflexive or a return path for only google.com to respond, and only for them to respond to that specific request. Meaning if Google just says, well, I just want to try and slip some traffic in there for some other host right now, it's not going to happen because the little eyeglasses on the router saw the request that went out. It said, I will accept a response to this request, but nothing else. Nothing else is denied, or everything else is denied. And as soon as that host closes its session with Google, the TCP session ends. Remember the TCP three-way handshake? That's what builds a session. Well, as soon as you close your web browser, it kills the TCP session. And now the deny all rules again. Google.com will not be able to come in unless there's a specific invite for it to come back. It's a pretty powerful access list. It's only one line. It's amazing, but it has a big effect. Therein lies the rules of the access lists, or what access lists are all about. I hope I was able to convey that access lists are not just for access. They're going to be used for all kinds of things on our routers. Access is just one of the easiest ways to explain what access lists are all about. We looked at, as we went through, using access lists for security, where the permit and deny statements are literally what is allowed in or out of an interface depending on how you apply it. So access lists can be used for security if they're applied to an interface. The types of access lists are like Skittles. We saw standard, we saw extended, reflexive, dynamic, time-based access lists. There's all kinds of them, but primarily in what you do day to day on Cisco routers, you will be using standard and extended. So in the next video, we're going to get into the configuration of standard and extended access lists, fully talk about what those options are, and apply them in some practical scenarios. I hope this has been informative for you, and I'd like to thank you for viewing.